Hi class, this is our fifth online lesson and our fourth in the series of dynamics. So far in the previous lessons we finished forces in connected particles, forces over pulley. Now this is chapter 5, force and friction. So far all the forces were horizontal, either horizontal or vertical. Now let us go to questions which involves forces with an angle, making an angle from the horizontal or the vertical. Like for example here now. This is not a horizontal or a vertical force. This force is making an angle of theta to the horizontal. Now in such situation you have to find the component of forces, and you have to find the vertical component and the horizontal component of this force. Like I have made diagram here. First of all, they have only drawn one force. Remember, there is a mass, so there will be a weight acting downwards, and normal reaction is always perpendicular to the surface. Remember this, reaction force is always perpendicular to the surface. And now this is a vertical force, this is also a vertical force, but this is making an angle, so we need to resolve it. So this is the vertical component of force F, this is the horizontal component of force F. Now if you remember your SOHCAHTOA, let us see here. The SOHCAHTOA, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tan is opposite over adjacent, sine is opposite over hypotenuse. Opposite, if you rearrange the formula, is hypotenuse times sine theta, which is exactly what happens here. The vertical component, because it is opposite to this angle, it is the hypotenuse which is the force itself. Always whenever you resolve, remember the force that you're resolving will become the hypotenuse of the triangle times sine theta, because it is opposite. Similarly, cosine will be adjacent over hypotenuse, so adjacent will be hypotenuse times cos theta, and that is why the adjacent, this horizontal force, is F cos theta. So opposite will always be sine, adjacent will always be cos. So now this is the vertical component of force F, the horizontal component of force F. Now let us take a look at this example. I'll draw the forces first. Okay, see, this is the normal reaction force here. This is that force F, let us say, that making an angle theta from the horizontal. Again, if I resolve, this is the vertical component and this is the horizontal component. Always remember, when you resolve, your force that you are resolving should become the hypotenuse of the triangle. In other words, the angle opposite should be right angle. So this is opposite, so that's why it is force F is the force you're resolving. So F sine theta, adjacent will become F cos theta. Same for mg, the weight is not vertical here. See, because we normally, and we will assume the plane to be horizontal. We will always assume, okay, the plane to be horizontal. So definitely this is not vertical. Then if this plane is horizontal, then this is the vertical force. So this force, the weight, is neither horizontal nor vertical, so we need to resolve it. Again, if I just go parallel, continue down from this y-axis, if I assume this as y-axis, this becomes your vertical force. If I assume this as your x-axis, so this becomes your horizontal force. And if this angle is alpha, this is opposite, so mg sine alpha. This is adjacent, so mg cos alpha. This was how to resolve the component of forces which are not either horizontal or vertical. I hope it is clear. Now let's move on. Okay, the question says, this is exercise 5a in your textbook. For each of the following system of forces, find the sum of the components in the x direction. The sum, the total in the x direction and y direction. Let us take the example, the first one. Okay, here. So this is that force. If I resolve, this will become the vertical component, and this is the horizontal component which I have drawn here. Now because this is opposite, this becomes sine, SOHCAHTOA. Opposite is sine, adjacent is cos. The force is 8. So 8 sine theta, 8 cos theta. So if I resolve horizontal now, if I resolve horizontally, if I take this as positive, this will be negative. So total horizontal force will be 8 cos theta minus 6. And vertically there is only one force. There is no force downward. So the total vertical component is 8 sine 60. Hope it is clear. Let's go ahead. Let us take this example now. Again, I would like you to pause your video here. Try to draw the components on your own and find the resultant force. Okay, let us start. Okay, so this force, if I just go vertical, just go horizontal, this becomes a vertical component, horizontal component. Same here. Okay, so now if I resolve right this as positive, the x component of this force will be this positive, so this will be negative, so it will be this minus this, which I have done here. Okay, if I resolve up as positive, both are up, so you will just add this plus this, because there is no force downward, there is no negative, there is no minus here. So this is the total, the x component of force R, this is the sum of y component of force R. So total R, if you know the x direction, you know the y direction, the total force we know from Pythagoras theorem will be the square root of x square plus y square, and that is how you get the resultant force which they are. What is the resultant force from these two forces? And if these two forces are applied, one making angle 50 degree of 25 Newton, the other making 30 degree from horizontal of total 35 Newton, there will be a resultant force of 39.32 Newton because of these two forces. They also asking the direction now. Again, for the direction we'll use simple tan theta. If I know the x, I know the y, I can use tan theta. Let us go to the next slide. Same, see, I know the x component, I know the y component, then the angle, you can use tan inverse of opposite over adjacent, and so you can say it is 60, the resultant force will make an angle of 68.8 from the horizontal or above the horizontal. Okay, next. Read the question. This is your task. It's same thing. I want you to try this on your own. Let's go to the next. Now, let us take this example. I want you to pause your video here. Try to solve on your own. Read the question carefully. They want acceleration, normal reaction. Okay, let us start now. A box of 5 kg lies on a smooth horizontal floor. A box is pulled by a force of 2 Newton. So with the force of 2 Newton it is pulled, but the force is making an angle of 30 degree. Okay, and causing the box to accelerate. Remember, whenever something is accelerating, your magic formula F equals to ma. Okay, let's see. First of all, this is a vertical force, this is also vertical, this is the only force which needs to be resolved. So this is the opposite side, that's why sine theta, adjacent side, that's why cos theta. So 2 sine theta and this 2 cos theta. Okay, now because it is accelerating, using F equals to ma, our same formula, if I resolve right to be positive, the result, there is only one force, there is no question of adding and subtracting. So this is the total resultant force equal to mass into acceleration, and you get the acceleration. Next, if I resolve upwards, now see, the object is not in motion vertically, it is moving on horizontal plane. So vertically you can say it is static. The next chapter after dynamics is statics, and in statics all our objects will be in motion or in equilibrium, sorry. So we'll be using this formula there. Okay, so you should know the difference. When the object is in motion, you use F equals to ma. When it is in equilibrium, the upward force will balance the downward force, as simple as that. So if I take upward as positive, object is not in motion vertically, so upward force will balance the downward force. So total upward force, this is a vertical upward force, this is a vertical upward force, so this two force will balance phi g. So this plus this give you this, you solve, you get the result, the normal reaction. That's it. Let's go to the next one. Same thing now. Okay, I want you to do this question on your own. You can pause the video here and try to solve. This is the question from your textbook, so you can check the answer at the back. Similar situation. I want you to do this also on your own. Remember, this is in terms of vector, so it will be much easier.